Hi friends, welcome back. Today we are going to solve LeetCode problem 165, compare version numbers. If you are new to my channel, I want to mention that my channel is dedicated to help people in their Java J2E and coding interviews. You will find lots of helpful videos on my channel that can be helpful if you are preparing Java J2 interviews or coding interviews or simply learning Java new concepts. There are over 400 different varieties of solved coding questions you will find on my videos, and those coding questions are taken from previously asked coding problems by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, and many other big financial companies. That will give you really good interview preparation because those interview questions consist of vast number of wide varieties such as BFS, DFS, matrix problems, graph problems, problems related to priority queue optimization problems, coding questions related to linked list, strings, as well as binary search related different coding questions. So you will find really vast varieties that you can practice and that will really be beneficial for you in your interview preparation. So please subscribe to the channel now. Let's start with the compare version numbers problem. So first we'll go through the problem statement, then we will understand this problem better with some examples and we will formulate our Java solution for the same, right? So let's start. Given two version numbers, version 1 and version 2, compare them. So they have given us two versions of, just like we have software versions, right? 1.0, then 1.0.2, something like this, right? Or 2.0.4. So they will be giving us two different versions and we want to compare those versions basically, right? So version numbers consist of one or more revisions joined by dot, right? So you must be familiar with this concept of version numbers consist of dot, right? Like 1.0, then 1.0.4, something like this, right? So each revision consists of digits and may contain leading zeros. So zeros also can appear in the leading positions, right? In the versions. Every revision contains at least one character. Revisions are zero indexed from left to right, with the leftmost revision being revision 0, the next revision being revision 1, and so on. For example, they have given us like 2.5.33, right? This is a valid revision number, or 0.1 is also a valid version number, right? So to compare version numbers, compare their revisions in left to right order. Revisions are compared using their integer value, ignoring any leading zeros. This means that revisions 1 and 001 are considered equal. So we are ignoring these leading zeros basically, right? So both are considered equal. If a version number does not specify a revision at an index, then treat the version as 0. For example, version 1.0 is less than version 1.1 because their revision zeros are the same, but their revision ones 0 and 1 are respectively 0, which is less than 1, right? So if you consider this 0 and this one, they are different, right? So based on that we will compare basically, right? Because this leading one are same in both versions, right? So we have to go forward and take a look at the next position, like 0 and 1 in this case basically, right? So what, like they have, what we have to return? So we have to return based on these conditions, right? If we find version 1 is less than version 2, then we will return -1, so that's fine. If we find version 1 is greater than version 2, then we will return 1, that's fine. Otherwise we have to return 0, right? So I think the problem description is pretty clear. So we will just look at, so they have given us few examples here. So the constraints are the version's length, right? The 1 and 2 length can be between 1 and 500. So both are coming as a string, as you might be seeing. These both will be given to us as a string, right? As you can see, these are strings, and that can be between 1 and 500, right? So 500 is the maximum length. They will only contain digits and dots, okay, and they are valid version number. So they are, so we can assume that they are giving us only valid version numbers, right? They already told us that in the constraint. All the given revisions can be stored in 32-bit integers. So That's fine. So let's take a look at some examples. We'll understand better using the whiteboarding session, right? So I created a few examples so that I can explain you easily. So this is our first example, right? So there are two versions which are given to us. So this is version 1 and this is version 2, right? So 0.1 is first version and 1.1 is second version. So if you just visually look at it, you will know that version 2 is bigger than version 1, right? Version 1 is smaller basically, right? So if version 2 is bigger, then we have to return -1 in this case, right? So we have to return -1 because version 2 is bigger than version 1. So if you look at this other example, right, this another example is there. So this is version 1 and this is version 2 that is given to us, right? So which one is bigger now? In this case, version 1 will be bigger, right? Uh, because this is 1.0, 1.0 is common. After that, we have to check if there is anything greater than 0 appears here, right? So 2 is greater than 0, so version 1 is bigger, right? So version 1 bigger means we have to return 1 in this case basically, right? So you got the idea, I think, what like the problem is. So now let's discuss how we can solve this problem, right? So this is related to string. So first we will actually convert this 0 1 and 1.1, right? 0.1 and 1.1 into array, right? So we will get two arrays basically, correct? So let's just call it array 1 and array 2, right? The first array will have 0 comma 1 here and the second array will have 1 comma 1 here. So I'll just write down for the first case so you will know. So after the converting into the array, we will get for the first array will be like this and the second array will be like this, right? 1 comma 1. So we are actually converting it using string. So these are string arrays, right? So 0 is a string, like 1 is a string, this 1 is a string, 1 is a string, like this basically, right? So we got these string arrays. So after that, what we will do is we will go through each position, right? So first thing what we will do is we will compare, like we will take the length, right? The minimum length we will take. So minimum length between 2 comma 2, correct? So 2 comma 2, because both lengths are 2, so minimum length will be equal to 2, correct? Because both are same length. So if that is the case, then we will go from this first position and we will compare these two, right? So we'll compare 0 with 1, right? So if we find something is like, let's say bigger, right? Let's just call this as a. So 0, a is 0 and b is 1, right? So we will compare a and b, and if we find the b is bigger, for example, right, in the comparison, then we will just return 1 here, right? Because in that case version sorry, if we find b is bigger, we will return -1 right there, right? Correct. If we find a is bigger means, for example, let's just assume that instead of 0, if it is, let's say 4, for example, right, then 4 will be bigger than 1, so v1 is bigger basically. So if version 1 is bigger, then we will just write there, we will return 1 basically, right? So you got the idea, right? We will just compare position by position, right, using a for loop. So 0 with 1, this 1 with 1. So we don't even have to go to this 1 because 0 and 1 are different, so it will tell us the answer right there, right? So this is case. So there are three different cases we have to handle in this uh, string problem of comparing version numbers. So this is the case 1. Let's just call it as a case 1, where we have both the lengths are equal now, right? Here also 2, here also 2, right? So both the lengths are equal. Now let's take a look at this case number 2. I created this another example to explain you how the case number 2 is different now, right? So now here, if you calculate the length of the string, right? So first we will get an array, right? So we will, how the array will look like, 1 comma 0 comma 2. So this is our first array, correct? And the second array will look like 1 comma 0. So array 2 is 1 0, right? So now as you can see, the length, we will take length, right? So lengths are not same because 3 is not equal to 2, so we know that. So um, so we will first take the minimum length, right? So minimum length is 2 basically, right? Minimum length between 3 and 2 is 2, correct? So which means that we always first will go and compare the numbers, version numbers, until this position, minimum position, right? Irrespective of their lengths. So for example, we will go here, we will compare this one with one, so both are same. So we will compare with 0 with 0, both are same, right? So we now reached the end of this minimum length, right? We already compared two characters, two numbers, so now we did not find any difference, right? So now this is the second scenario where we have to keep checking on the first version. So what we will do is we will calculate how much we have traveled using one character, like one counter. We will, let's say, integer I we will take, and it will, let's say, tell us the minimum length, which is 2, right? So what we will do is we will take the version v1 which is larger, and we will start with a position 2, because position will start with 0, right? This is 0, this is 1, so this is a 2 position, right? Because 0 based index. So we will keep going until the end basically on v1 side, right? If we find anything which is bigger than 0, right? It is bigger than 0, right? 2 is bigger than 0, so it means that v1 is greater than v2 basically in this case, right? v1 is greater than v2, correct? So that's how we will find out, and then we will just return based on this condition, right? v1 is greater than v2, will return 1, correct? If let's say we are going, and if let's say this is 0, for example, instead of 2, if it is 0, then both numbers will be same basically, right? Means because there is no difference basically, so in that case we will just have to return 0 basically, right? So you got the idea, right? So this is another same example of case 2 where v1 is greater length than v2, right? This is v1, right? This is v2. So as you can see, first what we will do, we will compare this 1 with 1, this 0 with 0, right? So minimum length is 2 between these two, so that far we already compared, we didn't find any difference, right? Which means that we have to compare the next these numbers basically, right? So we will compare 1. So as soon as we see something greater than 0, this one, we will just directly know that v1 is greater than v2 in this case, right? v1 is greater than v2, so based on the condition we will return the value, right? So this is the second condition that we have to handle. Now there is a condition which is vice versa, right? Where v2 will be greater in length than v1, right? So this is one of the example where v2, this is v1, right? This is v2. Now v2 is greater in length than v1, correct? So this is a vice versa condition. This is a type 3 basically, or case 3 that we have to handle, right? So what we will do, again we will calculate the minimum of these two. So 2 is the length of first v1, 3 is the length of v2, so minimum length is 2, correct? So again we will keep going, comparing for this first two character, 1 is same, 0 is same, so we didn't find any difference, right? So the only way now to know the difference is to compare this remaining version 2 strings, right? Remaining v2 basically, right? So we'll just mark here using this minimum length. So we'll start from here again. Now as soon as we see something which is greater than 0, we will just know from that point only that v2 is greater than v1, correct? So we'll, based on the condition, we will return -1 here, right? v2 is greater than v1, so it's -1. So this is the case 3. This is how we have to handle. This is another example of case 3 here, where this is our v1, right? And this is our v2. So v1 is length 2, v2 is length 4, so minimum length will be 2, correct? Minimum length will be 2. So again we will compare this first. First always we will compare until the minimum, right? So this 1 is same, this 1 is same. So we didn't find any difference, right? So we cannot tell, until this point we cannot tell which one is bigger, right? Now what we have to do is we will take this minimum length and point it here at the v2, right? Because there is something which is left over in v2 that we have to traverse to consider, to conclude who is bigger basically, right? So as soon as we look at this character number, this is one which is not 0, greater than 0, which we know that v2 is greater than v1 basically, right? and based on this we will return the value. So I think you got the idea how we have to handle the three different scenarios here. So it will be clear for you once we look at the Java solution. So let's go and take a look at the Java code now. So this is the Java code. Is pretty simple to understand once you understand the logic. So what we are doing here, so we are here, right? So we are using split method of a string. So it will split the string based on this regular expression using dot, and it will give us the array1 and array2 from version 1 version 2. So right, so the array1 array2 will look like this as I showed you here, right? So now we will take a length of array1 array2 and we will take minimum of them, right? So minimum of this length we are taking here into n. So n will tell us what is the minimum between these two. So first thing we always will do is we will go until the minimum length, right? So as I showed you here in this example, we will first always go until this minimum length, which is 2, right? And we'll compare those things first, right? So that's what we are doing in this for loop. So as you can see, it is going from 0 to n. N is the minimum length. We'll get a and b values, and we will have to use integer dot parse int, right? Because it's a string, so we have to convert it into the integer using integer dot parse int, and then we will compare a and b, right? If a is greater than b, then we will just return 1. If a is less than b, we will return -1. So this is based on the conditions they have given us right here. So these conditions. So this for loop is pretty clear, right? So we are going as I showed you, like this min length. Now if we don't find any difference, then we have to check for the further length, right? If the array1 is bigger than array2, for example, right? Array1 length is bigger than array2 length, correct? Which means that the version 1 is bigger in length than version 2, right? Then we will put our I pointer at nth position, right? Because we don't want to start from the beginning, right? We only want to start from this point, right? Correct? So that's what we are doing. Beginning part we already have compared, right? So that's what we are doing here. And we'll just do in a while loop. So while I is less than array1 length, we'll keep reading a value, like a value into a variable, and if a is not equal to 0, then it means that we can return 1 basically, correct? Because that version is bigger basically, which means that version 1 is bigger here in this case, right? Because array1 length is bigger than array2 length, correct? So exactly same thing we are doing in an opposite way when array2 is bigger than array1. Now array2 length, which means that version 2 is bigger than version 1 length, correct? So again same thing we'll do. We'll put the pointer I at the nth position, and then we'll go through the while loop, and we'll keep reading the values, right? For example, this example, right? So this example, let's say, so first this part we already have read, so we didn't find any difference, right? So we will keep reading from this next position, right? So that is what we are doing, right? So this is in this case array2 is bigger basically, correct? Array2 is bigger, and when we find a value which is greater than 0, correct, it's not equal to 0 means it's greater than 0, then we'll just return -1 here. Otherwise we will keep incrementing I. We have to keep looking, like for example, if let's say let's just assume that instead of this 4 and 6, let's say if this one is not 4 and this one is not 6, right? Instead of that, if it is 0.0.1 for example, right, then we will check here. So it's not 1, then we will go forward, we will check here, it's not greater than 0, it's not also greater than 0, we'll go forward here. Now this is greater than 0 basically, right? So we can conclude something, right? So that's what we are doing. So in a while loop. So, otherwise if we reach at this point, it means that we have to return 0 basically, right? So I think that's pretty clear. So let's take a few examples and run our code snippet. So these are the few examples that we discussed here, right? So let's just make sure that all these like test cases pass, and then we will go through their test cases and make sure those are also passing, and then we can submit it. So as you can see, we are getting all our answers correct. So for these examples that we have seen here on the whiteboard, so we can take their use cases. So these are their use cases, these three examples that they have shown us, right? So we'll just run our code snippet against it. So 0 0 -1, so we are getting correct answer. Expected is also same. So these are the examples that we just ran. So now we can just go ahead and submit this solution. So our solution got accepted by LeetCode. It is 23% on the performance side and 5% on the memory side. So so this is our solution for the LeetCode problem, comparing version numbers. So let's just quickly go over the what is the time and space complexity for this solution. So one thing you might have noticed that in case of let's say worst case, right? So worst case means we have this big version number and big like smaller version 2 number. So in this kind of cases, maximum worst cases, we have to go through all the characters here, right? All the numbers. So let's say let's assume that, for example, if these are total, let's say n numbers, right? Total n numbers are there, like 1 2 3 4 5 6. So total n you can say, and these are total m numbers are there, let's say, into this array. So the maximum we are doing actually is n plus m, basically, right? N plus m, we are visiting all of them basically once, correct, in our solution. So because this for loop, it will visit until the point n, and the remaining one, we, if it is longer, like if the both sizes are different, lengths are different, then we have to visit maximum remaining character once, right? So we will end up maximum visiting all the numbers basically, right? So this is, you can say, order of n plus n, n plus m, which is n and m is the total, you can say, numbers in this version number strings. So which means that you can say that the big O notation is order of n is the time complexity for this solution, right? Order of n, correct, because we are not looping like a nested for loop or anything. So this is the time complexity, right? And let's talk about the space complexity for this one. Is we are creating arrays for this version 1 and version 2, right? These arrays we are creating here. So this is the space that it will occupy, right? So if it is version 1 is n different numbers and version 2 is m different numbers, then space complexity will be order of, you can say, n plus m basically, right? Is the space complexity, right? So this is the space complexity because we are using external arrays, right, to hold the numbers, space complexity. So this is pretty good solution for the compare version numbers problem. So if you are new to my channel, there is a dedicated playlist called as LeetCode and LeetCode solutions. It has over 200 different varieties of LeetCode solved coding problems, which are solved and explained using whiteboarding sessions, just as we did now, and for your easier understanding, and they are also explained with Java solutions. Apart from that, there are other important playlists as well on my channel. The names are Code Chef, Code Forces, Add Coder. So over and all, there are like 400 different varieties of problems you will find, which are solved and explained for your easier understanding, and those are taken from different varieties to cover a wide range of varieties such as BFS, DFS, matrix problems, graph problems, problems related to priority queue, optimization problems, dynamic programming problems, coding questions related to strings, linked list, also lots of logical questions that can be solved with different data structures such as set, map, queues, stacks. So you will find really good examples if you are preparing for your coding interviews and Java interviews. If you like this video, if you find this video helpful, and if this video help you in understanding this problem better way, easier way with these whiteboarding sessions, then please give it a like. Also subscribe to the channel. Your subscription to the channel is really important for the channel because that is the way the videos can reach to more people who need help in solving coding problems. one of the main goal of the channel is to help people in solving their coding problems, so they can understand how to approach different varieties of problems using Java data structures, and how to use Java data structures, APIs, libraries to solve different varieties of coding problems. So they can also watch these problems and get helped during their interview preparation. So if you like this video and if you find this whiteboarding session helpful, I would like to know about it. So please write in the comment, because I want to know if the whiteboarding sessions that I do in the videos are helping people in understanding. So please write in the comments so I will know about. So I just wanted to get the feedback about the videos. So please write in the comments. Also, your friends are preparing for interviews, please share these videos with your friends and colleagues. They can also watch these different varieties of coding problems videos, and they can also get helped during their interview preparation. I'm gonna share the Java solution code that we have seen here on my GitHub account, so you can check it out the code from there and play with the code with different examples, unit test cases for your better understanding. If you like this Java solutions, and when you are taking it from GitHub account, then please consider giving a star to the project on GitHub, so that might be helpful. And thanks for watching this video.